For centuries, humanity's greatest discoveries have been preceded by a new instrument. Let me explain what I mean by that. The telescope revealed the cosmos. The microscope revealed the cell. These new instruments allowed us to see what was already there, but hidden. These new discoveries were hidden. I believe that Git is doing the same thing. Today, our newest discoveries are not hidden in the very large, like the cosmos, or in the very small, like the cell, but rather in the very complex. Guys, we have a huge data problem. And I believe that we don't need a new telescope or a new microscope to fix it. We need a macroscope. And I believe that the answer to us has been with us for the last 20 years. It's the Git that we all know and love. By raise of hands, how many of you guys have faced a Git clone problem where it has taken more than a minute? 5 minutes? 10? So it's a problem that all of you guys have faced, right? But what can we do about it? Today, I hope to talk about that and also give you a toolkit to work with. So first is this command here. Let's show a quick demo. So usually when we have long commit times, right, there's two options. There's two possibilities for why it might be taking such a long time. The first is if you have a big repository in the sense that it's very old. That means that it has a long list of commits. The other option is if it just has a lot of large files, right? A lot of large project assets. Let's talk about both of those. So first, let's look at shallow cloning. And at this talk, we keep coming back to the Linux kernel, and I'd like to honor that as well. So let's clone that. Clearly, it's going to take a really long time here. We're still at 0% a few seconds after starting the job. And it's just taking a long time, right? We'll talk about a strategy for mitigating that later. The second type of big repository is if you have large package files, project files. For this one, we're going to use Stability AI Stable Diffusion model for image generation. This is a gigabyte or two large. And that was pretty quick. But if you notice here, I added a filter blob none command. And this is for partial cloning. You're not downloading any of the large file storage files here, or the pointers that come with it. And because of that, your workspace remains clean. You get to choose exactly what files you want to download. If we had ran git clone, we would have also had to run git LFS fetch. So that's the git clone filter blob none command. OK, so that was a quick thing. Let me talk a little bit about myself and introduce myself to you guys. My name is Piyush Acharya. I'm a senior in high school from Bellevue, Washington. But more importantly, I'm a builder, just like you guys. I love GitHub. GitHub's been my home for the last 5 years. And I'm really happy to be talking about it with you all today. So you see, a few years ago, I wanted to take a DNA test. People know about the ancestry benefits of DNA tests, right? But I was more curious about the scientific and medical benefits that it offers. For example, it can tell you what conditions you might be susceptible for. It can potentially diagnose you for certain conditions. It can also tell you about what your nutrition diet should be. So I wanted to take one. But then I did a little bit of research, and I realized that the industry right now is pretty messed up. The big players in the game have a lot of data privacy issues. Just 2 years ago, the data of 7 million customers got leaked by one of the big players in the game. So I decided not to take a DNA test and make a freely available open source project called DNAnalyzer. And the basic premise and the core idea of this tool is you can now analyze your genome on device locally. We run all of the analyses and machine learning models on device. And so your data stays on your device, stays with you. It never goes up to the cloud where it has the possibility of getting leaked. And why might you care about your data getting leaked? Well, it can lead to your insurance providers hiking up your premiums. It can also lead to identity theft. So it's a pretty big issue. We are currently at 162 stars on GitHub. I presented it at Y Combinator's Mini YC, and we also placed top 10% in A16Z's speedrun. So the project was starting to get a lot of traction. But then we started hitting an issue. A lot of contributors started filing in. But if they wanted to make a quick edit to the README or edit a simple algorithm in the project, they have to download the entire repository. It's more than 200 gigabytes large. And so just to make such a simple change, they had to download all of this stuff. And contributors were coming to me, and they looked like this. And so I had to fix that issue, right? And so that's where the partial cloning comes in and shallow cloning. Those were pretty big time savers for a lot of our contributors. You know, we need to care about our contributors, right? They're very important. So yeah, in this talk, I'd like to talk about Git LFS, shallow cloning, filter process, and GitHub's own spec kit that was released just a few weeks ago. So let's start with shallow cloning. People talked about this earlier as well. It's really useful if you know about it. I didn't know about it until just a year ago. But it allows you to only download the most recent commit. Filter process is kind of like GitHub's Git's pre-commit hooks, but on steroids. It can do many of the same things, but you can also many of the same things as in linters, the job that linters do. At DNAnalyzer, we use it for removing patient metadata and other critical information. And so it can also use for protecting your secrets and API keys as well. It's just one extra guardrail preventing you from committing something accidentally to your repository. Okay, and a quick talk about SpecKit. So how many of you all have vibe coded before? Not a lot of people. I would have expected to see more people here. Come on, guys. But if you vibe coded before, you know that AI saves you a lot of time, right? But it has this tendency to hallucinate and kind of go off the rails and go on tangents. It tends to add a lot of extra stuff that you don't want it to add. So SpecKit solves that issue for agentic AI coding workflows. And the way it does it is by setting a constitution that your AI model, your agentic tool, must follow the entire time. And the reason why this is better than like other such options is because it supports all of the CLI tools and agentic workflows that you might use. Gemini CLI, Claude Code, Codex CLI, VS Code's Copilot. All of them are supported here just by creating one constitution. So I would encourage people to look into this. It's awesome that I'm able to talk about this in the same building where probably the people who make this made it. So yeah, definitely check out SpecKit. All right, before we end here, I want to leave you guys with one final thought. In a recent talk, Andrej Karpathy, who was the director of AI at Tesla, co-founder at OpenAI, framed the evolution of modern developer tools in two parts: augmentation and autonomy. Git has provided us developers augmentation for years, right? Git commit, push, pull, fork, etc., allowed us developers to organize and collaborate more effectively. But now we're entering the next era of Git, where it's providing autonomy to us. We're able to tell Git what to do. And we saw the next level of that through SpecKit and filter process, where the repository has a mind of its own. It's able to make decisions. I believe that the question is now not how do we manage big repositories. It should rather be, what do we want to teach our tools to make? Thank you.